Okay, what I am doing is I am back on the intake manifold for the Cummins A3 for the haul truck. I made a series of videos starting to show you how I was going to construct a intake manifold out of carbon fiber. So here we are, and what I should point out is that this is going to be a destructible mold. In other words, I'm molding the carbon fiber and Kevlar around this thing and then gonna extract the mold out of the finished product. Okay guys, it's been so long since I posted a video on this project. What I'm going to do is throw a link up there to part 5 of this series so that you can go back and see it if you're new to the channel, if you're new to this episode, whatever. But here we go. So I have never done this before. I was originally thinking about making the intake manifold out of steel, and then I thought, let me try my hand at seeing what I can come up with. Now, I really haven't done a lot of searching on it. I've done some searching on it, but basically the parts that the people are making on YouTube are like bonnets or hoods, fender flares, stuff like that, or interior parts to dress it up. This thing is, like I just said, going to be a destructible mold. I'm not looking to have this thing appearance-wise look good from the outside. Yeah, I want it to look like carbon fiber and I want it to look as good as possible, but my main focus and my main intention of this thing is building an intake manifold. I'm not building a showcase intake manifold. I'm building a functional manifold that will help this engine breathe better. So again, it's going to be destructible. Now, I have seen some videos on the subject of how they made two parts of a mold and joined them together, but they never really got into how they joined the layers or interlapped the layers of a part that was going to be needed to be strong as far as having forces upon it. I've seen them do it. I've seen them do it, but they never explain. You know, what they would do is lay one section of the mold in and kind of ply apart the layers of the carbon fiber, but they never said how they joined them in the mold. And I don't really want to flange a mold in half, in other words, split this thing so that it's two different sections with a flange in the middle. That would create another weak spot as far as I'm concerned. So it's going to be a destructible mold. I'm going to lay the carbon fiber around it. Then after it dries, I'll go in from the bottom and in from this end and pick out all of this foam that I have used to construct the mold out of. So again, time has really escaped me. I didn't realize how long it had been since I posted this last video. Again, I'll leave a link up there. I know that I'm not a fan of links up there because when I'm watching a video, I don't want to be interrupted in the video that I'm watching by clicking on that and going to it. Well, I'm in the process of watching the original video, so I'll also leave a link to it in the description if you want to go back and see it. But again, destructible mold. Now back to where I left off. So this is it. This is the mold that I have gotten so far. Yeah, that's it. And what it's going to do is kind of set on it like thus. So if you don't understand what I'm talking about, this is the old intake manifold, and it was very restricted. Number 1 cylinder being down this way, number 6 down that way logically, and as you can see, 5 and 6, even though the runner on the head and the intake manifold go down that way, the airflow was very restricted going into this thing. This engine, this A3 engine, did not have, like most Cummins, does not have glow plugs. It had a intake grid heater, but these intake grid heater actually was not like the ones that are found on the 6.7 or 5.9. It actually had diesel fuel injection into this thing with like a spark igniter, and it would actually create a fire in the intake manifold. But that being given, the intake was very restricted in getting air into it. So hence, this is what I came up with. Kind of looks like the head off of an old Kirby vacuum cleaner, doesn't it? This is what I came up with, and because of the flow characteristics of this thing, it will get air flowing down towards 5 and 6 cylinders. I'll take you over at some point in time and show you the head, but you'll understand what I'm talking about. The head is on the bed of a mill, and I've got to flip it over so that you'd be able to see it. But anyways, let me explain to you what I'm doing here. This flange has to be created on the bottom of the intake manifold. So what I'm going to do is, because this all has to come off of here, there has to be some kind of a release agent on it. What I'm going to do is create that flange down in here. I'll build up an area around this thing, and it's going to be bigger than this, and then what I'll do is I'll lay it out on the bottom side of it and mill it off, or to create these curves. But I want to create a big flange and then be able to cut that flange down to form the shape of this. These notches are essential in here in this head, and I'll explain to you that when I show you the head. But anyways, so I'm back working on it. So what I'm doing is just making a base plate, and then I've got to build up an area around it to create the flange. So however thick that flange is going to be, on this it's probably, what, 3/8 of an inch? Yeah, good guess. 3/8 of an inch. It'll probably be at least 1/2 inch. Okay, so I got interrupted. Somebody came into the shop, and while I was talking about this. But what I was saying is, what I'm going to do is create a flange that is bigger. So let me address this fact, and I've told you this in other videos. Sometimes I'll pull off of something and do something else for a while so that I can think about things. Basically, here is a flange on this. this is this. What my thought process was is if I build a replica of the outside of this flange and then have the intake on the inside of it, it is going to be extremely hard to lay that carbon fiber and or Kevlar and or both into here to create this flange because of it's so narrow. So, and then it also has all these jogs in it. So what my thought was that I was thinking about is, okay, why don't I just create a wider flange, which is easier to lay in, get the material in, get it in there and bonded real good, and then just come back and make a template of what the outside of it's got to look like, and I can cut it out with a router or on the mill or something like that. So that's where I'm going with this thing. So these dotted lines that you kind of see around here is where I'm going to take it out to, and then I'll just cut it off. So the second thing that I was thinking about while I pulled off of this is the carbon fiber and Kevlar going to be strong enough in with those bolt holes with that little of material in between the outside and the edge of the bolt hole. So my thought process was, do I need to put metal in there? Do I need to kind of create this flange out of metal and incorporate it into the carbon fiber base so that the flange is strong enough to withstand the pressure of the bolts? So what I'm thinking now is that was when I was just going to use carbon fiber. Now what I'm thinking about doing is interweaving carbon fiber and Kevlar into the flange. And I also might incorporate Kevlar cross supports into this thing just so that I know that it will be strong enough, have like a support strips around there, just so that I know that it's strong enough to withstand the pressure of the turbocharger. So, yeah, here we are with this thing. This board, I'm just, maybe I'll use it, maybe I'll use something else, but it's kind of a layout pattern as to where I'm going to go. I do need to have something like this, whether maybe it's a piece of MDF and that I can put down and then build a framework around it that's maybe a 1/2 inch thick or maybe even more than a 1/2 inch thick to create this flange. But then I've also got to use it to support the structure. So this thing will be there, but I need to kind of keep that up there. So probably what I'll do is put some kind of a pin in there that can go down and so that it holds it up in the upright position as I'm laying up the carbon fiber over this. But anyways, there's where I am with that, and we might get more of it into this this episode. So here is the head off of the A3, and it was laying down on the bed of the mill, not face down, so valve rocker arm side down, laying down on the bed of the mill. Actually, you probably see it. I was trying to get out some broken studs, exhaust manifold studs. But so here is the intake manifold. Yeah. Let me just think here a minute. So maybe I was wrong about yeah. So I was wrong. When I showed you the template, I told you that 5 and 6 cylinder were buried back in there. It's actually 1 and 2 that are buried back in there. 6 is also buried back in there, but not as bad as 1, the number 1 cylinder. Yeah, yeah. That is number 1 cylinder. So 1 and 2 are kind of buried back in the housing, so that plenum will go over the top of this. So before, that thing was just feeding in like here, and you could starve air both by how restricted it was and because it wasn't feeding the entire length of this opening air into it, how restricted it was. Sometimes when you get a thing like this on a 6.7 or a 5.9, it's 5 and 6 cylinder that are this air intake plenum is farther forward on the 5.9 and 6.7, and it ends midway through number 5. So number 6, 5 and 6 are kind of starved for air sometimes. But anyways, there it is. One of the things I forgot to explain to you, the notches in the intake manifold flange, these 4 notches here, what it is that's where the injector goes down through. So there's a possibility I could leave them notches out and keep it straight. The only thing is, if I did that, you would have to take the intake manifold off to get the injector out. I'm not saying that because of the new shape of that intake manifold, we can go over here and look at it and see where those notches are. See, this one and this one would be clear. You might have had a problem getting the getting the injectors out that way. But anyways, it's all things that have to be worked out. I'll bring you back. Okay, we're back over to the table and where I had originally started this video. And I just want to explain a couple of things. This video, which is going to be number 6 in the series, I think, is more of a re-explanation of what I am doing, how I'm doing it, why I'm doing it, and etc. Because it's been so long since I published the last video. I want this to be a kind of a reintroduction to it, but also at the same time kind of explain my thought process behind some things. One of the things that people might be saying to themselves is me making this flange wider and then cutting it down to fit the profile of the existing flange on the intake of the head might raise concerns with people of me cutting it and creating stress cracks in it from the cuts. What I'm going to do is, after I cut it, I'll reapply resin. I want to say epoxy, but it might not be epoxy resin with the carbon fiber, but so let's just call it resin. I'm going to reapply resin to the areas that were drilled, bolt holes, and cut around for the flanges, the notches, etc. So that's going to take care of that. Now it's going to be Kevlar and carbon fiber in here to help strengthen this flange, but in the same time, on the top of it where the bolt goes through, I'm probably going to place a washer on top of it too, to help distribute the stress load of the head of that bolt out over a larger area. And between me applying resin to cut and drilled areas, using Kevlar and carbon fiber and a washer, it should not present a problem with cracking or stress fractures where the bolt goes in. So let's talk about stress fractures. I told you that I was going to use Kevlar to do the flange, but I would also might wrap it up over here because this thing is going to be pressurized, and I'm not really sure what turbo I'm using yet, but let's say that we could build boost pressure up to around 40-50 pounds. I kind of want to make sure that this thing is going to be adequately supported or be reinforced to take those expansion loads that comes with pressurization. I don't think it would be an issue with the carbon fiber by itself being layered and cross-layered, the pattern being cross-layered, but at the same time, I want to double check myself and just reassure myself that I'm going to be strong enough in it. So I am going to bring that Kevlar up over it and put a couple of reinforcing in it. Now, I'm not an engineer. I designed this thing by the seat of my pants, and I'm sure that there's an engineer out there that has some formula that could equate the strength loading of the plies of carbon fiber and cross hatching to this thing and tell me how much pressure it will hold. But I'm not that person, and I don't know that person. And how they would equate it to, because being a curved surface provides more strength than being a flat surface. So I don't know how that formula would work and how it would adapt to this particular shape. So so again, I'm kind of flying by the seat of my pants, and I'm going to overbuild just to appease myself that I've got a product that I don't have to really worry about. So given that, the other thing that you have to kind of take into consideration when building this thing is the engine, vibrations from the engine that will be on this, and heat that will be on this. And although the plenum, the air plenum on the side of the head is hung off of the side of the head, and really not that much heat is going to be transferred into it, it's still going to be warm. But carbon fiber, Kevlar, good heat dissipation on the shape of this thing, I don't think that's going to be a problem. Nor do I think engine vibration, because this thing is going to be affixed solidly to the head, and it's going to have a silicone hose that comes off, or silicone boot, let's call it, that comes off from the intercooler. So that's going to be, that would be flexible. And so this thing is going to move in conjunction with any engine movements you get from it. So you really shouldn't have any stress loads. If this area was solid, supported like over to the truck and solid, and it would be, you would have a solid thing off of the truck and engine vibrations which would affect each other. But because it's going to be flexible and not rigid, rigidly supported to the truck, it will move and flex with the engine. So I'm not really concerned about vibration either. But again, I think it's over-designed with both, going to be over-designed with using both Kevlar and carbon fiber. And I'm really not concerned about those factors. But anyways, let's have this be it for this video, and the next one I'll be working on making this the board that is going to be built up on, the support for this, and the dam around it that is probably going to be built up to make the flange. But anyways, thanks for watching, guys. Hit that like button, subscribe, leave a comment too.